So, and y'all can still see the slide that I put up?
Yep.
Cool. So thanks to everyone who has joined the call. My name is Ed Carley. I'm Senior Program Director for NASEO's Buildings Program, and I lead our Buildings Committee. And we're pleased to have you here today for a webinar on refrigerants for a variety of products. But the reason we wanted to bring you this webinar today is that this is a really important topic that we've been hearing about from folks for the last couple of years, as there's a lot of concern about the impact of refrigerants, which in many instances have, the existing refrigerants have high GWP or global warming potential. And so when these refrigerants escape from the appliances into the atmosphere, they can be quite harmful. And so as momentum to shift towards heat pumps increases, we see a lot of concern about the potential for fugitive emissions of refrigerants from appliances. So the industry is responding to this concern and to some international actions that have occurred and some actions of the United States Senate and of the US EPA and others to move to more or less harmful refrigerants. And so we're going to hear today from representatives of Carrier, Johnson Controls, and from AHRI, the Air Conditioning, Heating, and Refrigeration Institute, about what they're doing and why. And we're just going to do kind of a primer on refrigerants, what we're interested in and what we're concerned about. And so we'll take questions from the audience at the end. If you do have like a technical question or something you don't entirely understand, please raise your hand. And so as you may have heard me say earlier, we're in a Zoom meeting format, so you will be able to unmute and ask questions, but that also means that you'll be able to unmute and disrupt accidentally. So please do be sure that your microphone is muted and there's no accidental Zoom bombing. So that's no fun for anyone. So with that, I do want to thank our speakers for joining, and I'm gonna hand it off in just a moment here. Actually start to do that. So we're gonna go with Nick Harbeck, who's the Manager of Regulatory and Environmental Affairs at Johnson Controls next. Nick will be followed by Jason Thomas, the Director of Regulatory Affairs at Carrier, and then Samantha Slater, the Senior Vice President of Government Affairs at the Air Conditioning, Heating, and Refrigeration Institute, AHRI, will close us out before we go into the question section. So let me stop my share. And then Jason, I think you should be able to share your screen if you're ready.
Nick, you mean?
Nick.
Yeah,
sorry.
I think that might be my cue.
All right, thank you, Nick. All right, well, I will hand it off. Thanks so much.
Yeah, awesome. Thank you, Ed, and thanks again to NASEO for having us today. This is a pretty complex topic, so we're really eager to be able to collaborate on this and walk through some of the things that we've been seeing, and hopefully can hear some perspectives from folks on the phone on how we can handle this transition. Today, I'm going to be speaking specifically about the AIM Act, the American Innovation and Manufacturing Act, which is the piece of legislation that has been the impetus for many of the things you're about to see today. So I have a couple pieces of background that we're going to go through. And like Ed mentioned, if there's any questions about any technical things on the slide, please feel free to chime in. There's a lot of pretty complex and dense information here. Today, I'm specifically going to be talking about the AIM Act itself, and then the authority that EPA has been granted through the AIM Act, kind of in this line of reasoning from the Montreal Protocol back in 1987, and how it's been used to allow the EPA to regulate equipment, the management of refrigerants themselves, as well as allocation or the production and consumption of refrigerants that are used in our technology. So for a little bit of background, the Montreal Protocol on substances that deplete the ozone layer was an international agreement back in 1987 that established the phase out of these harmful ozone depleting substances, CFCs and HCFCs. back in 2010. That was kind of the tail end of the scope of that ozone depleting substance regulation. But the refrigerants that were developed to replace those existing ODSs were also discovered to be potent greenhouse gases. As a result, in 2016, the Kigali Amendment to the Montreal Protocol, so the same protocol, a new amendment to it, was established and helped to update the scope of substances that are regulated through this international agreement. Specifically, it ended up targeting a phase down of those HFCs to help reduce the global warming potential of the gases and these short-lived climate pollutants that can enter into the atmosphere, and prompted international agreement as well as local action kind of across the world. And that's where the EPA ends up coming in. So the AIM Act is legislation that is intended to help bring in the aspects of the Kigali Amendment to the US. For a little bit of background, again, the Montreal Protocol was a treaty that was ratified for that ozone depleting substance regulation across the world. The US helped to implement through its own Clean Air Act. And the Kigali Amendment was thought to maybe potentially originally be given authority through that Clean Air Act, but the court struck that down back in 2017. So new authority was needed. And as a result, the AIM Act was born. Congress passed that back in 2020, and it provided EPA with authority to do a few things, which I'll get to on the next slide. Unfortunately, the Senate also ratified the Kigali Amendment. So we have two sources of kind of backup for making sure that the next generation of refrigerants is phased in appropriately as HFCs phase down. So what's included in the AIM Act? The AIM Act does a couple of things. It's specifically addressed to the Environmental Protection Agency and allows them to phase down the HFC production and consumption in the US. This is known as allocation. So what this means is the Environmental Protection Agency can determine a methodology for how much global warming potential of a particular chemical can be produced and consumed in the US, and then go to manufacturers and importers of those products and say, you're allowed to produce this much HFC. Specifically in GWP equivalents or global warming potential equivalents. This gets updated every year, and the methodology can also be updated. But EPA has essentially authority to say how much refrigerant can be used in the US. The second piece of authority that it has is related to refrigerant management. This is a little bit more vague than maybe allocation, but essentially the EPA has the authority to set up reclamation programs, refrigerant management programs, and other ways to incentivize the kind of maximal reclamation of existing refrigerants, such as R410A, the most common refrigerant in use today, kind of across the HVAC sector, and then minimize releases of equipment itself. You might have seen this, historically, there have been fines for venting refrigerants, for example. There's also potentially incentives that could be used under this authority that the EPA could set up. So we're hoping to see a new rule come out soon related to HFC specifically. I understand that's currently at the Office of Management and Budget. So more to come in the second space here, the second tranche of authority, but we expect to see EPA doing that. And then finally, the one that I think is the most applicable to what y'all will be seeing in the next couple of years is the technology transition, or the authority for EPA to facilitate the transition to next generation HFCs through sector-based controls or restrictions. A couple of years ago, AHRI, NGOs, other industry partners worked together to develop a couple of proposals that were sent to the Environmental Protection Agency and proposed these initial technology transitions that EPA should consider in its kind of authority and goals of reducing global warming potential refrigerants. The first of these rules have already started to be go through their formal regulatory process, comment, etc. And we're starting to see kind of the fruit of that labor with a new technology transition rule that is expected to go into effect January 1st of 2025. So with these three areas of authority, the EPA is on track to meet its obligations under the Kigali Amendment and the AIM Act to phase down HFCs and reduce the global warming potential of those chemicals and ensure that the new chemicals and the next generation refrigerants that are coming in to displace those existing HFCs are able to meet our goals and also meet the supply and demand that's needed for this pretty massive transition. I'm sure anyone who's lived through, the transition from ODSs will see some corollaries and some similarities between the two as these phase down steps occur. Just one thing to note again, I'll just emphasize this here. The Kigali Amendment has a phase down of HFCs rather than a phase out compared to the ODS restrictions under the original Montreal Protocol. This is important because it'll allow for the continued service of existing equipment in the field and ensure that good operating equipment that doesn't leak too much is still able to function into the future and reduce some of the uncertainty that can be associated with a complete phase out. And while also ensuring we still meet all of our environmental goals and obligations. So I'll highlight quickly the technology transitions here. Like I mentioned, the EPA can restrict the use of HFCs and HVAC-R and water heating equipment, the most notable of which is going to be this potential targeted ban of R410A in new manufactured equipment starting in January of 2025. EPA does a couple of different things to make sure that products are ready for these new refrigerants, and I'm sure Samantha has a bevy of information related to the codes and applications of that. But through the significant new alternatives policy program, which is a piece of regulatory information that EPA puts out, it states and lists refrigerants that can be used in these pieces of equipment. So for example, the condensing unit that you see here on screen currently can use R410A in the US. It's pretty common. And with the authority under the technology transition rule, in combination with these SNAP rules, EPA is going to allow the use of new next generation refrigerants. And I won't steal too much of Jason's thunder, but they have different safety and performance characteristics, which require new listings to be able to meet these standards, building codes, legislation, et cetera, for use across the US. There will be some requirements in terms of building code updates, legislation updates, but again, more to come there. But essentially, R410A is going to be phased out for most of the products that you see today on the side of people's houses starting in 2025. Now, how that's happening, here's the deadline itself. EPA is setting a 700 GWP limit for products containing the 410A that you see today. So that means that next generation refrigerants such as R32, which has a GWP of 675, or R454B, which has a GWP of 466, are allowed to be used in these products and kind of replace the current slate of R410A products across the US. There are a couple things within this proposed rule that EPA has set up, including a date of manufacture basis for when that ban goes into effect. There's a currently 1-year sell-through provision allowed. So as you see in your states, equipment is imported and produced and brought to your state in March, let's say, of 2025. They can still be sold through with a R410A, but currently as proposed, once December 31st hits, all equipment will transition over as the installed base transitions entirely to these next generation refrigerants. The classification of some of these new refrigerants is that they are mildly flammable, according to AHRI. Jason, I think, has some pretty good information on what that means, but the technical definition is a burning velocity of less than 10 centimeters per second, which in my mind is hard to comprehend, but I promise you it means something. And finally, as Samantha will get into later, the state building codes must be updated to make sure that these new refrigerants can be used, which is where a lot of the state partnerships can come in. Finally, just to summarize, this is what the phase down schedule looks like for refrigerants across the US. You can see that we have this 40% phase down target over the baseline, which was established under the Kigali Amendment to achieve global warming potential reductions that are needed under the Kigali Amendment. And in practice, this is where the technology transition that EPA is going to be implementing is going to help us meet our goals. In fact, it's likely to exceed that 40% reduction, especially for the HVAC-R sector, and get us a little bit closer to that 70% reduction that we expect in the late 2020s. But more will be needed in other sectors. This is just the first of probably many transitions that will occur, but this one is a pretty big one and a pretty substantial contributor towards mitigating some of the climate change impacts from these maybe older refrigerants that are going to be phased out and replaced with next generation items. So again, more SNAP rules will be coming. I'm sure more regulatory information will be coming as the refrigerant management program rolls out through EPA. There will be more information there. So there's a lot still happening. But there's good news that EPA is taking action today, especially related to these technology transitions, which will come into effect very soon to a state near you. With that, I'll end my slideshow presentation. I think, Jason, if it's okay for you to share, I'll stop sharing and pass it over.
Sure. Thank you, Nick.
Yeah, thanks a lot, Nick. I'll cover a little bit while Jason gets his slides pulled up. That was really helpful. So looks like that is coming up. We're in the presenter view. No, that's the right one. All right, I'll hand it off.
All right, thanks everyone. So I'm going to go into a little bit of technical details around the refrigerant, just very high level. These are information that we share, frankly, with our contractors and distributors in the channel, helping to prepare for this. This first slide here is just a little bit on refrigerant changes over time. So you can see it's going way back. We had a high ozone depleting refrigerant and high GWP. Then we moved to a lower ozone depleting refrigerant and lower GWP, but still not where we wanted to be. For today was no ozone depleting. We actually moved up a little bit in GWP. And then now we're moving to no ozone depletion and a much lower GWP. I mean, the main takeaway, and I guess what we share with customers on this slide is, yes, the history, but this isn't our first rodeo. We've changed refrigerants several times. We actually, as an industry, we worked and launched all the 410A products that went into effect in 2010, and it wasn't too many years after that we are already starting to work for this refrigerant transition. So a key message here is we got this. We're all designing every product we make right now, but we're on path and on target to get this done. As Nick talked about, he shared a little bit around mildly flammable and A2L, and I would say there's a lot of misconceptions about the refrigerants we're moving to in the field. I often get questions like, oh, you're moving to propane, or these things are explosive, and that's not the case at all. So I wanted to share with you what the AHRI classifications are. I actually start at the bottom and work up. So the current refrigerants that are used, particularly in residential, is 410A. It's at the bottom. It's classified as an A1. It's no ignition. As tested, there's no ignition. Now we're moving to 454B, R32, as Nick explained, and that one they actually created a new classification because it wasn't quite. It didn't quite fit the A1, so it wasn't like there was no ignition, but it also didn't fit the A2, which is ignites pretty easily but has relatively low energy release. You can see the example above it. So that's why they created this A2L category. To give you a frame of reference, it's about like lighting coal. So there's a picture of coal on the side there. So if you think about, we use that all the time. If you have a coal grill, not explosive like propane. So propane's at the top. It's an A3. Obviously, it ignites very easily and is explosive. You'll hear conversations around natural refrigerants, and maybe you might ask, well, why are we going to these refrigerants that are 700 GWP? Why not go to zero? Isn't that where we ultimately want to get to? Well, that's because propane is a good option for going to zero, but as you can see, it's highly explosive, and there's a lot more work that needs to be done from a safety perspective and technology perspective to get to that point. So what does this mean from a flammability perspective? And I'm not going to go through this very tech engineering chart on burning velocity versus heat of combustion, but I think why I did include it was it shows you from a relative perspective where these things land on the chart. So 410A, this current refrigerants all the way there on the left, lower left. You can see it. Zero burning velocity, but it will burn. And then 454B, and not shown in here is R32, but both of those are roughly about the same. You can see they're not far off from 410A, whereas propane is up there around TNT, and I mean it's obviously highly explosive. So you can see the differences there. Now, maybe you might be saying, well, it's still mildly flammable. Actually, like a few years back when I was in a different role, actually an engineering role, presenting this to customers, I got called out on main stage because I said, oh, they're mildly flammable, and one of the customers laughed and was like, mildly flammable, what does that mean? Flammable is flammable. So there is things that we are doing to mitigate the risk of a leak, and so I wanted to show you a little bit what you might see in the products at a very high level. So products will have a leak sensor, and that will be located in the indoor coil cabinet. So the purpose of that leak sensor is to detect a refrigerant leak if there should be one, and to mitigate any chance of ignition. If the unit turns the blower on, it's not possible to ignite the refrigerant. it dissipates very quickly. So that's what the safety standards require, is that if a leak is detected, the blower comes on. And so that requires a sensor change as shown here on the slide. And then it'll also require, changes within the control boards and stuff itself. And as you can see, this is just an example here. All of us manufacturers are doing all the hard work of placement of these sensors and all these things in our product as we launch it. The last thing I wanted to point out, so there will be label changes. So 5 new labels, one saying, hey, this is flammable, as you can see on the left. And then labels kind of calling out low voltage wiring and care taken there. What is somewhat unique that doesn't exist in product today is that label there in the center, which really kind of tracks the refrigerant in the product and is expected for customers to use that label to track the refrigerant quantities in the product. And then, really just, again, to call out that, hey, safety needs to be taken. One of the things I tell customers, which is thankfully, since smoking is reducing in our country, but if you were to be charging this and working with the unit and you were smoking a cigarette and there was a leak, it wouldn't catch on fire. Now, if you had an open flame right by the leak, it would. So that just kind of gives you some contextual knowledge, I guess, if you will, on the flammability. So I went through all that pretty quick. I didn't want to go into too much technical detail, but I did want to share with you, again, we've all got this. We're all working towards it. A lot of work's been put into the safety standards. And that's where Samantha's coming in, and she's going to talk about what we've been doing to get those safety standards in the building codes and make sure that's all prepared.
All right. And if you can see that, we might be getting somewhere. All right, everything works. Since Jason was talking about flammability, I'll share my favorite comparison that I talk about on the Hill, and that is more flammable than these mildly flammable refrigerants is the jar of olive oil above your gas stove. So if that helps you, that helped me think about it. So that's my favorite example of what we're actually talking about when we talk about flammability. Thank you all for having me this afternoon. This is one of our favorite topics to speak about. As you can tell, I'm Samantha Slater. I'm the Senior Vice President of Government Affairs at the Air Conditioning, Heating, and Refrigeration Institute. Our members are the manufacturers of HVAC/R and water heating equipment, 2 of which you just heard from, and several others I see on the participant list here today. Nick and Jason set me up perfectly. Nick, I'm going to go back to something you said right up front, and that people might notice the corollaries or the similarities from previous transitions. And Jason was talking about flammability, and that is really the difference between previous transitions and the work the industry has had to do for this one that we haven't had to do in previous transitions. And the major part of that, in addition to passing legislation and ratified in treaty, which if you had asked me 4.5 years ago, I would have told you would have been the toughest part of this. And actually the toughest part of this whole transition, I feel like, will be ultimately when they are all said and done. And that is changing the building codes in states and localities to allow for the use of these low GWP refrigerants. I have no trouble telling you, with several of my members on the line, that I think the industry underestimated what it would take to do that. Again, this was part of previous transitions that the industry didn't have to undertake, and it has certainly been a great challenge. But I actually think we're getting there, and certainly in the last 6 to 12 months have made a great deal of progress. As both Nick and Jason mentioned, what you need to know at this point about this transition is that once we get through the technology transition final rule, that will restrict the use of the current refrigerants Nick and Jason both mentioned, 410A. And updates to state and local building codes will be necessary so that this new equipment can be installed and used in states. So over the last 2 years, the industry, and I'm going to include all of our members, there is no doubt that this has been a joint effort, truly a joint effort between the trade association and all of the expertise and help from our member companies, particularly with the state building codes over the last 2 years, to have as many states as possible before we get to the January 1, 2024. If you remember Nick's chart, noting the Kigali Amendment step down phases, we're coming up to a big step down in January 1 of 2024. Our technology transition petition is for January 1, 2025. And even though that is what the industry requested at EPA, we know that we need to start that transition and have as much new equipment being able to be installed to states as possible ahead of that January 1, 2025 date. So the industry has undertaken this year a massive effort, particularly at the legislative level, which we can get into, to go into as many states as possible and pass building code legislation. Let me be very clear. The legislation is merely a Band-Aid or a bridge to allow us all the time that we may have to take to work through the different state and local building code processes. So we have always known, even if we are working on legislation in a state, that we will have to go through the building code process as well. So in almost every case, it is a parallel process. But in order to be ready in 2024 and 2025, in many instances, with the pace of the building code process, we really had to turn to a legislative effort. I know that probably wasn't the preference of a lot of the regulatory building code agencies, but in order for the industry to be able to move forward, that's what we needed to do. So this year, AHRI engaged lobbyists in 25, 26 states. We had passed legislation about 10 to 12 states in 2021 and 2022, but knew that this year, it's an odd year, legislatures are all in session. We had to make our biggest push to make that happen, and that's exactly what we did. It also took several years, as Jason mentioned, for the safety standards to be updated, which needed to happen so that they could be SNAP listed. They both talked about the significant new alternative refrigerants. So there was a lot of work that had to be done over the last 4 years in order to be ready to go to the building code councils and the state legislatures to make this effort happen. But we have finally gotten there, and we made this massive push this year on legislation, and which also fortunately resulted in many building code councils speeding up their work on this effort as well. So I'm going to go to the next slide, which is our famous map. Couple of things you have to keep in mind when you look at this map. Please look at it from the perspective of a legislative effort. We have many other documents, spreadsheets that'll keep you busy for hours that will go through the entire building code process. But when you look at this map, what I hope you see is a lot of baby blue. And those are states where legislation is in place, and we have that bridge that will get us ultimately to the building codes being changed. We have had a couple of failures this year in our legislative effort. Hawaii and Nevada, they simply ran out of time, and we were part of hundreds of bills that didn't make it across the finish line. Nevada, we were actually vetoed by the governor as part of a larger gaming association effort. And in Kentucky, we ran out of time there as well. So we have some work to do next year in those states, but we've had great successes this year, as you can see by all the baby blue on this map. We have 4 states left to go, and they are in session for the remainder of the year in Wisconsin, Michigan, Massachusetts, and New Jersey. If anybody can offer help in those states, we will 100% take it. Absolutely. We have several states that are on the governor's desk awaiting signature in Alaska, Illinois, New Hampshire, and Delaware. And I think we're pretty close in New Jersey as well. So hopefully soon New Jersey will be color-coded purple as well. So there is a lot of information that could be on this map, but it would start to look like a Jackson Pollock painting and just make everybody crazy. So just please keep the legislation and that effort in mind when you look at this map. If lists are more of your thing, and this, we can talk a little bit about the active building code work going on. This list is not definitive. Let me be clear about that. As I mentioned, we are active in many, many states, but this is the list of the states that have an ongoing regulatory process that we are actively involved in currently. I hope we are close to the finish line in California, where we also have legislation in place. Our members have done a great job in the District of Columbia for us lately. We thought we were going to have to do legislation this year, but that legislative effort spurred the Building Code Council into action, and great work by our members in the District of Columbia. We still have work to do on commercial refrigeration in Florida. We are close to the finish line, hopefully in August, in Georgia on the building code process. We are doubling back efforts in Hawaii, thanks to our failed legislative effort there to get the codes done this year. If not, we will work on legislation again next year. We failed on our legislative effort in Kentucky, but we hope that the governor's office, who we have already met with, can help us find a pathway to an emergency order to get the codes in place as yet this year. We are still working to finish the commercial refrigeration code work in Louisiana. I was devastated by the governor's veto in Nevada. That was a key state we wanted to get done through a legislative effort this year. Since we couldn't make that happen, ultimately we will work with the two largest counties in Nevada to try and find an alternative again for the remainder of this year and the early part of next year until we can take a second shot at legislation in Nevada. Oregon, we still need to get commercial refrigeration done. South Carolina, the same. And we are hopefully, fingers crossed, coming to the end of the regulatory process in Virginia. So you can see the chart there. R means residential, C means commercial refrigeration equipment. And then we also have to go back to all these states except for West Virginia and go back and do our warehousing updating as well. If this chart tells you anything, it's that there is an enormous amount of activity to change the building codes to allow for the use of these low GWP refrigerants going on. Again, we will take all the help, advice that we can get to make this happen so that we can start selling equipment in as many states and localities as possible by as soon as possible, but definitely January 1 of next year, and ultimately by January 1, 2025. Every time I feel like we're never going to get this done in the next 18 months, my members remind me that this will absolutely be a race to the finish, but they have confidence that everybody in the building code space works best under pressure, and they will absolutely work to get this done. So I'm holding out hope for that, but it is definitely a group effort, and this will 100% take a village. And again, anybody who wants to jump in and help, we will take that help. Ed, I'll turn it back over to you.
All right, thank you, Samantha, and thank you, Nick and Jason. That was fantastic. So, Samantha, just help me understand the stakes here. So, if you don't get this building code legislation passed, will I be able to buy a new air conditioner?
Come January 1, 2025. No, and that is the point we make in state legislatures. That is a good talking point. It's not a talking point I want to use. I hope I don't have to go there. But it does seem to be an argument that gets people's attention. Really, the way we talk about it is it's a timing issue, right? And building code councils have a wide variety of schedules and processes that they have to go to. We understand that. Legislatures do as well, which is why we had to start this process early, right? So that we have options, and that states have options, and that customers have options. And so we're just trying to do everything that we can so that we can get the timing to line up so that everybody who needs equipment can get the equipment that they need and that they want, and that will keep them comfortable and safe when they need to. But ultimately, we're all trying to get to the same place. It's just going to take a little bit of a windy road in some instances to get there.
Thanks. So let's see. So I haven't seen if anyone in the audience has questions. And maybe that I don't have the chat pulled up, but I haven't seen any questions come in. So feel free to use the reactions button to raise your hand. you can come on camera and unmute, or you can put a question in the chat if you don't feel like speaking up. But so a couple of more questions. So let me see here. So sorry, let me find my notes. So Jason, are the manufacturers going to have products ready by the transition date or earlier?
Well, yeah, so I mean, we're definitely going to have products available by the transition date. Our investors would not be happy otherwise. But no, I would expect to see, I mean, we didn't go into this deep level of detail, but or I don't know if this clearly stood out, but next year there is a refrigerant supply phase down ahead of the equipment transition. So I would expect you're going to see in the states where we can some products hitting the market next year. That's my prediction.
So
but yes, be ready.
So a lot of our members are getting ready to implement the homes and the high efficiency electric homes rebate program, HERA program. So they're, you know, obviously one of the drivers for that whole program is to reduce global warming emissions, greenhouse gas emissions. And so you know, it's good to hear that these products will start to be available to help speed that transition, because I've heard some folks express concern about installing a bunch of heat pumps with high GWP refrigerants and sort of not making any progress because of that. So I do see Mike Turns has his hand up. So Mike, I'll let you have the floor.
Hey, thanks, Ed. Yeah, so I'm with PSD, and we're the lead vendor for the Massachusetts Codes and Standards Compliance and Support Initiative, which is a mouthful. So this is on behalf of Mass Save. And one of our contacts there has actually expressed interest in refrigerants. They're specifically, I don't think they're well versed in it, nor am I. But they were specifically interested in propane, which you mentioned, and Jason, I think it was, said that we're a long way off. So I guess that will lead to part two of my question. But I guess part one is more of a comment that maybe there's an opportunity to work with the utilities. They call themselves program administrators in Massachusetts, but to work with them to help support legislation or whatever needs to get done. So I'll get in touch with you on that.
Thank you.
And then, yeah, my second part is, since they had expressed interest in propane, I guess it's used in some applications now. Jason said it was kind of a ways off. I'm curious, like, how far off is it, and what needs to happen?
Great question. Propane is a great refrigerant, and it is, you know, used in some applications that have really low quantities of refrigerant, like really small quantities of refrigerant. As far as being used in North America, under our current product construction, where you have a unit sitting outside your house and you have refrigerant lines that run in the house, and you have refrigerant that, you know, a coil that sits on, you know, sits on top of either electric heater or gas furnace, and then you're running propane through that. There's a lot of safety standards more than anything that has to be thought through and considered before we'd be ready for a transition like that. You know, to get put in context a little bit, you know, even with this refrigerant, we did a lot of work and research at at UL. We actually worked with the fireman community, because, as you might imagine, and I don't blame them, they have concerns of, hey, we're going into this house that is on fire. What's this refrigerant going to do? And so there's just, you know, all that to say, I think, you know, there's just a bunch of activity that would need to happen to have that. And one of the comments I often hear too, and I'll stop with my long-winded answer, is like, oh, well, we have furnaces that use propane. What's the difference? Well, the difference is this is pressurized propane, highly pressurized propane. So that's some of the reasons why I think it's a farther out.
If I could do a quick real quick follow-up. Do we think it's headed there eventually, or do we think it's a dead end?
Well, I mean, I would say my company's point of view is if we're going to get to natural refrigerants, there's a couple leading candidates. I think it's one of the leading candidates. But it will be a pretty drastic change in the architecture of a system in the US, meaning you will end up not having refrigerant running into your house. And then that changes how things work, quite a bit, but to be determined.
Okay, thank you.
Thanks, Mike. I see Erin Kepster has her hand up.
Hi there. Yeah, thank you for this great information. I think to date I've heard a lot more about like drop-in replacements and how systems can be retrofitted with lower GWP refrigerants. And I think it was a webinar put on by Tecumseh a while back that started to go into a little bit more about what it would require to actually be able to do that in existing systems, because there might be different actual mechanical systems needs for that. I'm just curious to hear your thoughts on the feasibility for doing drop-in retrofit replacements of the refrigerant in existing units, whether you think it's going to be sort of a bespoke solution or if it's something that's really viable at scale.
So, I'll take this, and then Nick, I don't know if you want to chime in or not. So our company position is that we're not advocating for drop-in for a couple reasons. Number one reason is because the 410A systems aren't designed with the same safety measures that a system, that 454B or R32 system would be designed, and it creates a lot of safety risk to then, someone buy a sensor, figure out where to put it in the inside. I mean, there's a lot of work going on from us as a manufacturers on the position and placement of the sensor, tying that into the furnace, making sure that the safety mitigation does its job. So that in and of itself creates increased safety risks, and so we not support that, and the codes and the standards aren't supporting that either. And then additionally, above and beyond that, there is tweaks in the design of the system for these refrigerants. And so while the system would operate, it wouldn't operate as efficiently, or could operate with less efficiency than it would otherwise.
Nick or Samantha, did you want to add on?
Nothing too much. I'd probably exactly echo what Jason mentioned. I mean, even with refrigerants today without drop-ins, we see changes in performance based on charge alone. So introducing that extra variable of a new type of chemical going into a system could pretty substantially affect efficiency, like Jason said. So in addition to the whole safety issue itself, the performance of the equipment would likely suffer without optimizing for that new fluid. Not to say it can't be done, just probably a lot more challenging once it's in the field, especially.
Thank you.
Great, thanks very much.
So, Nick, in addition to the code changes, what needs to happen at the consumer and installer level to advance low GWP refrigerants?
Yeah, this is a great point. Thank you, Ed. From a state perspective, looking at it as this new whole swath of equipment that's coming out of the field, and like you mentioned before, especially with this likely increased uptake of heat pump technology due to the Inflation Reduction Act, this new lens of refrigerant adds a few extra wrinkles into it. So, we see both from a training perspective, making sure contractors know how to handle these new refrigerants safely is going to be a key. I know within Johnson Controls, I know Carrier and many other OEMs have started their own training programs to help socialize some of this information. But any sort of alliance we can, broker with the states themselves to make sure that this information is getting out there is going to be hugely helpful. Especially when it comes to things like the contractor going in and getting new equipment, for example. A manifold today likely can't be used with the next generation refrigerants we see coming in the next couple of years due to those safety considerations. So there's a little bit of this growing pain that we're going to experience. But once we get over that hump, and especially if we're able to communicate all of these things out there, we'll be able to transition much more effectively.
Thanks, Nick. So Samantha, I'm curious, so I'm going to throw you a little bit of a curveball. I'm curious what kind of engagement y'all have been doing, AHRI has been doing with the other building industry stakeholders, because as I'm sure you know, code updates can be challenging. So I'm curious, so how has the messaging gone? And what are the code is quite broad, right? Here at NASEO, we talk a lot about the energy code, but are we talking about the energy code, or are we talking IMC or different elements of the code?
We are. So first, let me thank all of the various stakeholders that have been a part of a coalition around the entire HFC phase down, whether it was legislation or ratification or state legislation or work in the building codes. This has been an amazing coalition of environmental NGOs, advocates in the business community, in the industry to get this done. It is, something that has been agreed to 15 years ago and worked on to get to this point. So I have to say this is one area where finding a coalition to work on these things has been really a joy to participate in, and having the support of the contractors, the distributors, the environmental community. It's really been a great group of people to work with. That doesn't mean we won't take more, because it is going to take a lot to get us across this finish line. But we've had great support from all of the industries that we traditionally work with, and new friends that we've made along the way, as everybody wants to see these new low GWP refrigerants into the marketplace. So thank you to everybody who has helped on this effort to get us to this point. It's really been a broad coalition. You are right, and I will tell you, 4.5, 5 years ago, I did not know anything about the building code process. And I have learned a lot, and I hope I never have to use it again. As you all talk about propane, I start to get anxiety and break out in hives in the building code effort that it would take to do that. It would certainly take more than the $7 million that the industry invested in research and training, and would encourage folks to go to AHRI's Safe Refrigerant Transition webpage, where there are webinars galore and information that you can find on additional training that you may need, and we are happy to help as well. But the building code process, whether it was ICC or the IAPMO process, we have been engaged in all of it, some more successful than others, some more challenging than others. But I think we're close to getting across the finish line and getting the states to where we need to be. But to say that it has been a challenge and an education for a lot of us in the industry, dare I say all of us in the industry, certainly an understatement.
Let's see. So there was one thing, so warehousing came up. I viewed the slides. So help me understand what warehousing refrigerants has to do with building codes.
Oh, that is part of the process as well. So not only are we have to store these mildly flammable refrigerants, right? So that they all have their own set of building codes that have to be addressed. So that is one of many moving parts of this issue that we have to take care of, whether it's residential, commercial, warehouse.
So, sorry, did I interrupt somebody, Jason? I saw you're not muted.
No, go ahead.
So does that require changes to like the IMC or the mechanical code to allow that?
And that has all been done. It's just
Okay.
a matter of getting the states to adopt. And as you well know, there are states that are on the 2012 code, back farther than that. Some states that I've discovered that have a strategy of staying one step behind, which just makes you makes these kinds of things challenging, right? When you're trying to get everybody up to the current code so that we can use these refrigerants, and that's just not what they do, right? They stay one step behind. So again, that goes to the challenge of this, is trying to appreciate and understand the decisions and why they've historically made those decisions, but also trying to relay the fact that there is this transition coming, and we need to be able to make sure that you have equipment to purchase when the time comes, understanding your philosophy around building code adoption, but also needing to make sure customers and your constituents have the equipment that they need. It's been very interesting, to say that we have learned a lot, truly an understatement.
Yeah. So is there buy-in on this transition from home builders? I mean, they're typically one of the most powerful interests in the code adoption process. And are like, where are they coming down? Are they helpful, or are they, less interested in seeing this update?
So there are certainly different coalitions of home builders out there, and going all the way back to the AIM Act, certainly have had concerns that they've voiced and expressed. But as we've worked on state legislation, the majority of instances, they have been a good partner in getting this done. We've also had opportunities to go speak at recent conferences, so that we can try and better understand what their concerns are and what our goal is. And I think those conversations, particularly this spring, have been fruitful, but they have been a partner in our legislative effort many times over the last few years.
Okay, that's good. Good to know. And then I see there's a question in the chat from Mike, who said, so if a state adopts the 2021 IMC, problem solved? Question.
2024.
2024. Okay, so we're waiting for the new code to even be published. All right, that's good information to know. Let's see. So so that's when all of the building codes will be updated in 2024 to allow the use of A2Ls. Is that correct?
To the 2024 code, they all states, again, effective dates.
All the model codes.
All the model codes in the 2024 edition. Okay.
Then the state's got to take the action to pull in those model codes and do all that
It does
work.
have different effective dates, as does legislation. It's
it takes, there's a period of time, and that I wouldn't expect that 24 code to be published. Well, if we're lucky, it'll be published early in 2024. Monitoring the way it's going, at least on the energy code, I'm not so sure, but I guess we will see.
hence the need for legislation to get us, build a bridge.
Yes.
And get us to where we all need to go.
Yeah. So how might this transition? So, there's all these supply chain concerns. We've heard concerns about the availability of heat pumps to meet the potential demand from the HERO program and the homes program. Is this transition going to have any impact, do you think, on states or on consumers' ability to buy that equipment and get it installed in their homes in the next 2 or 3 years?
From our perspective, no. I mean, the nice thing is we're deep in the design process. I mean, we're deep in our development process, have been for quite some time. And, we see that out there, know that, and can make plans for it.
Okay, good. Let's see, I'm looking at the questions I jotted down here. All right, so just so I want to be perfectly clear on this issue of what codes need to be updated. So if I'm a state and we choose to not adopt certain parts of the code or to do so on a different timeline, but obviously my residents, my businesses need heating and air conditioning. What are the code chapters that I need to make sure get
Oh,
updated.
I have a whole document that I can share with anybody
Yeah.
who'd like that, with a wide variety of options, 60 pages worth, that they can choose from to do that. So I am happy to share and send that over to you, Ed, if you
Okay.
think you have members who would appreciate that. Happy to do that.
We can put that up with the recording of this webinar.
Fantastic.
Yeah, I think we'll do that. So with that, we're towards the end of the hour here. I want to thank you all for joining this webinar. That's been really helpful for me to understand the issues around this refrigerant transition, and hopefully it'll be of value to our members that came today and to the folks who watched the recording. So thank you so much. We really appreciate your time.
Thank you.
Thank you all.
Take care.